Good day everyone. So today I'm going to share with you a discussion video about volume of a solid of revolution. More specifically, the methods of how to solve the volume of solid of revolution. If a plane area is rotated about a line on its plane, the solid thus generated is called a solid of revolution. So the line about which the area is rotated is called an axis of rotation. So for example, in this figure, if you have a plane area here, it is represented by a rectangular plane. And if I will try to rotate this rectangular plane, right, in its axis of rotation or the line L, I can form a solid. So the volume generated by revolving the rectangle about a certain axis is called the circular disk. So if we will try to represent it in a Cartesian coordinates, we have my vertical axis, which is y, and my horizontal axis, which is x. And this is my curve, right? My curve here, which it is represented by f of x. Y is equal to f of x. And my boundaries is from x equals to a to x equals to b. So I want to get the volume generated by revolving this area about the x-axis. So with that, I need to draw a strip. So this is my rectangle or rectangular strip, which it will be revolved about x-axis. So if I will try to revolve this rectangular strip and the bottom part of my strip touches the axis of rotation, I could form a circular disc, right? Which the x here represented by the change of height, and my y here is the distance from my axis of rotation to the point of the curve, to a point of a curve, which y is equal to the L, or the length. Alright? So if you want to get the volume generated by revolving um, this area using circular disc, this is equal to volume is equal to pi integration of length squared times the change of height from your A to B. With this Cartesian plane, it is represented by V is equal to pi integration of length, which is y, that's y squared, times dx, which is the change of height, dx from A to B. If the lower end of the rectangle does not rest or touch the axis of rotation, which here it is represented by L, the solid revolution generated by revolving this rectangle here or rectangular area here about a certain axis, which is L, is called the circular ring, or we also called it as washer method. Previously, that was about the disk method. Now this is the washer method. So you could form a circular ring like this one in the figure. So let's try to represent this in a Cartesian plane. Let's say that this vertical axis here is our L, which represented as the length, and the horizontal axis is represented by H, which is the height. And I have my two curves here, G1 for the lower curve, G sub 2 is for the upper curve, and I have my parameters from A, which is H is equal to A, to H is equal to B. If I want to get the volume generated by revolving this area bounded by these two curves and the parameters about or rotated about in each axis, I need to know some certain details. First thing that I need to know what strip that I should use. For this one, I will make use of the vertical strip because it need to be perpendicular to the axis of rotation. With this one, because it's perpendicular, though you do have the bottom part of your strip doesn't touch the axis of rotation, therefore you could form a circular ring. So first thing that you need to know is your strip, then next is the length of this one. All right, length of your strip. So okay, this distance here from here is the change of height, or dh. And we need to know the distance from your axis of rotation to the upper curve, which is represented by L sub 2, and the distance from the axis of rotation to the lower curve, that's L sub 1. Therefore, this distance here is represented by L sub 2 minus L sub 1. So if you want to get the total volume generated by this figure, revolves around H axis. So you need to know the volume generated by the length sub 1, right? And the volume generated by length sub 2. So you need to subtract L sub 1 or dV sub 1 to dV sub 2. So therefore you could make draw this kind of figure, or you could have this figure. So if the ring, this is the circular ring, so if this circular ring will move from your lower limit to the upper limit, you could get the volume generated by revolving this area here. So getting the volume generated by this area here using the circular ring method, or the washer, that's V is equal to pi integration from A to B times the quantity of L sub 2, that's the length sub 2 squared, minus length sub 1 squared times the dH. So that's how you get the volume generated by this area revolve around a certain axis using washer method. So the difference between washer and the circular disc method, in washer you have space, right? You could form a ring. In circular disc method, you just form a disc. And the strips in the circular ring is perpendicular, or it touches the axis of rotation. While in washer or the circular ring, hindi. Yung bottom part ng strip mo, hindi mag-touch sa axis of rotation. So if the rectangle has its edges parallel to the line L, the solid of revolution generated by revolving it about L is a cylindrical shell. If your strip, right, if your rectangular strip, or the area of your rectangular strip parallel to the axis of rotation, therefore you could form a cylindrical shell like this. This is the cylindrical shell. So let's try to represent it in a Cartesian plane. So let's say that this vertical line here is the vertical axis, which is L for length, and the horizontal line here is represented for height, and this is H. So we have our curve here, which is G, and our lower boundary is A, and to the upper boundary, which is B. So if I want to get the volume generated by this area revolve around the axis L, I need to know some details. First thing is you need to know the strip that you will use. So if you will make use of the cylindrical shell method, your strip should be parallel to the axis of rotation. So with this one, we will make use of the vertical strip, because the vertical strip is parallel to the axis of rotation. Alright, this is the vertical strip and it is parallel to the axis of rotation, which is L. So by that, we need to know the length from the axis H to the curve, which is, it is represented by L sub 1. That's the length. And we need to know the height. So the height represents the distance from the axis of rotation, right, to the part of the curve, a part of the curve, which is this part of the curve or part of your strip. So this is represented by h sub 1, and the distance from here to this part of the curve or this part of the strip, it is represented by h sub 1 plus the change of h, where the change of h is the distance from here to here. So if you try to revolve this strip here, this rectangular strip, you can form like this. So getting the volume, that's 2 pi integration of HLDH from A to B, which this is all about, or it is represented by the cylindrical shell method. Because you will form a cylinder, that's why it's cylindrical shell method.